We're going to learn how to use X-Plane Plane Maker. So when you download X-Plane 9.0, you get an icon for X-Plane, and you get an icon for Plane Maker. And Plane Maker is what we're going to talk about today. So we're going to double click on that to launch Plane Maker. And we're going to create a new airplane. This is one that I was working on today. So choose that menu. And the way we create an airplane is we enter the values for the different pieces and parts of the airplane. So that's what I'm going to walk you through. We'll enter data for a wing, vertical tail, horizontal tail, fuselage. So you can follow along if you have X-Plane brought up. So the first thing I want to do in your handout on page 1, you should see a thing that says X-Plane 9.0 on the top. And it says Wing 1. So the way we get there is we pick the menu up at the top. So we go Standard. So you might need to write this down. You click Standard, and then you choose Wings. And you get the menu that you're looking at on your screen or in the handout. And we need to enter the length of the wing. And it's done as a semi-length. So the wing, half of the wing is 18 feet. So we're going to enter 18. And I did that by clicking on those arrows at the top until I got 18. And you notice that nothing is showing up. If you look at the right, there's a picture of our airplane as we build it. And now we need to tell it the chord, because right now the chord is 0, which means it has no width. And the chord we're going to give it is 4.9. And the tip chord, this is an airplane that has a rectangular wing. So the tip chord and the root chord are the same. I'm going to show you a trick on how to get to 4.9 faster. You go up to 5, and then you hit the down arrow, and it goes back to 4.9. See how that worked? So I went to 5, and then these down buttons will take you back. So there's some short ways you can do it, or you can just enter the values. So we specified, I've got the semi-length wrong, don't I? That needs to be 18. There, that looks better. Now if you look over at the right, you see our wing. And it's got just a placeholder fuselage, default fuselage there. And then the last thing we need to do on the handout, if you notice there's check boxes down at the bottom of the screen or in the middle and the bottom. We're going to tell it that we want ailerons to be on the outboard 3 stations of the wing. Yeah. You can bring X-Plane up if you want. Well, that's what he's looking to find. You can just follow along on the handout and make notes on there. So are we caught up? Is everybody good? All right. So, yeah, so as you're following along, the longitudinal arm is the location of the wing in the axis along the fuselage. And in this airplane, we want to go to 7. Notice it moved the wing back. And it's all relative to whatever the XYZ origin of the axis for the airplane is. And we're choosing the origin to be at the nose cone of the propeller, at the very tip of the airplane. And so the wing is located 7 feet aft of the very nose of the airplane. So that's all we need to do to define the wing. We give it how long it is, what the chord is, that is what the thickness is. And you can give it a sweep. We're not going to sweep the wing because this is a glider that's just a rectangular wing. But if you do this, you can see you can sweep the wing back and make it look cool. Or you can give it some dihedral, that is, you tilt the wing up like that. So you can make the airplane look pretty much however you want. The lateral arm allows you to shift the wing left and right, and vertically you can shift it up and down. So when we're done with this, this is a bit odd. He has his own graphical interface here. Normally in Windows, you push the X and it cancels everything you did, right? To close this down and save, you just push the X up in the upper left or upper right corners. So I'm going to click on the X, and there's a picture of our airplane. I wanted to show you that first. Now let's go back to that wings menu, because in the wings menu, we're going to click, and it's hidden behind, it is on my screen, there's a menu here called horizontal stabilator. So we're going to do the horizontal tail next. So everybody grab that. So this is now on your next page of your handout. So flip over to that. And again, this is just another wing. It's located in the back. So we're going to tell it the semi-length, the root chord, and the tip chord. And by the way, we're making a glider, but it's based loosely on a Cessna 182. I pulled up the data for that, and that's where I got some of these measurements for the wing size and so on. No sweep, no dihedral, but we do need to move the tail back. And measuring from the picture on the airplane, the tail is approximately located at 22.5 feet aft of the nose of the airplane, which is our datum. If you look on the right, the picture shows you now that's shifted back, right? If we wanted to do a high tail, a T-tail, we could shift this up and put it up high. But this airplane, we're going to leave it lined up. On the horizontal tail, we want to put an elevator, so we're going to check the boxes on elevator all along the whole span of the horizontal tail. No sweep, no dihedral, so I think we're good with this menu as well. Now we're going to put a vertical tail on there, so click the menu up here that says Vertical Stabilator 1. So that's going to put the vertical tail. Notice that the dihedral is already set to 90 degrees. So this is just another wing that's tilted 90 degrees straight up to be a vertical tail. And we do the same thing. We'll feed it the semi-length, the root chord, and the tip chord. And we're going to make this look like a real vertical tail, so the tip chord is going to be less than the root chord. And we're going to sweep it back 30 degrees to make it look like the vertical tail. And then we're going to stick it back at the back end of the airplane. Like that. And then we're going to put a rudder on it. Like that. So I think that means we're done with the vertical tail. Hang on a second. I'm looking for another page here. Oh, we're good. All right, so what? Yeah, that's a mistake on the handout. So there shouldn't be a checkbox there. And I just noticed that today, that somehow that got in there. All right, so now we need a fuselage to connect everything together. So we're done with this, so X this out. Then go to standard and go down to fuselage. And what we're seeing here are cross sections of the fuselage in each of these windows down here. And this is more of an art than a science. You grab the points on the fuselage, these little X's, I'm sorry, the little squares, and you drag them to get the cross section of the fuselage that you want. And we need to locate them there in certain positions. So I'm going to put the nose of the airplane further forward just to make it look good. So I'm going to put that at -4 and -2. And on the very nose, you notice when I grabbed one of the squares, it went to 0. It does that so that the fuselage ends. So that's the very beginning of the fuselage. And then you can grab each of these squares and drag them in. I'm not going to spend a lot of time doing this. But if you spend time, you can make it look pretty cool. We're going to leave that at 2, 3, 4, 5, 6, 7. And then we're going to start tapering the fuselage. So I'm going to push this up to 18 because remember the tails are back at 22. And we're going to put the very end of the fuselage back at 25. And then we're going to taper, we're going to make essentially a tail boom starting 7 feet aft. And then again here at the very end, when you click on one of the squares, it will pop it down to 0 because that's the very end. This is one of the ways to edit the fuselage. If you pick the screens, the tabs at the top here, you can look at it on a top and a bottom view, so you can actually move stuff around here as well and make it look good. It's a little harder to edit here, I think. And you can look at it from the front and the back as well. If you need to make it bigger or add more stations, you can add numbers here. And the body radius of 2 feet, we could crank this up if we wanted to make our body radius bigger. So you can make it look right. And again, this is kind of an art, so you spend some time on this. But it doesn't look too bad, huh? For just a quick fuselage. Did you figure it out?
Yeah, so on some of the computers, it's under the user profile flight sim. And for some of the computers, they're under the public response, so they show up with.
So some of them are on this login, that
Yeah.
login, local login.
They log into that, they'll see the. So later on, I can make one way or the other, or it's only on the flight sim desktop or
I think it's on that one for X-Plane 11 and 10 because we have a license installed.
Well,
So I don't, if putting it on the regular desktop messes it up.
I'm not sure because I don't remember how licensing works.
Yeah.
You just have them just log on the flight sim.
Yeah. Okay.
Check the rest. I'll take the computers later.
Okay. Thanks. Let's see, we got the fuselage done, right? So flip over to the next page in the handout. So that's the vertical tail. So now we need to tell it about the controls. We put ailerons, rudder, and elevator, but we didn't say anything about how far they can deflect, up or down, or left or right. So that's under standard and control geometry. So far all the menus are under standard. And here's where we tell it how big the aileron is. That is, what percentage of the chord the aileron comprises. So we're going to say that the aileron is 20% of the chord. And notice you have the one side of the aileron and the other side, so you can actually make the aileron smaller as it tapers down with the wing. We're going to keep it simple and just do 20% chord. And then here we need to tell it that the aileron can go up and down 20 degrees. And again, this is related to just the mechanics of the aileron. So if you know your airplane, you know how far it can go up and down. The next thing we need to do is the elevator, because we didn't have a second aileron. So the elevator chord ratio we're choosing is 30%. And its chord ratio, it can go up and down 20 degrees. And then we need to do the rudder. So the rudder is a 30% chord rudder. Sorry, 50%. And it can go left and right 30 degrees. So that tells us how far each of those surfaces can deflect. And if we wanted to add a flap, we could. That's the stuff on the right. You can put a flap in. We're going to leave the flap off because then you have to add some instruments into the control panel of the aircraft to deal with that. So we're not going to do a flap today. So we're done with that. And if you look at the animation here, you can see the control surface is moving, which is really nice because you can tell if you botch something up. If you forgot to put in the plus and minus 30 degrees on the rudder, you won't see it moving. The one thing that you have to remember is if you look under the special menu, you might have to toggle this thing called show with still or moving controls. Because if you toggle that, they stop. And then if you toggle it again, they move. So if you pull it up and you look at it and they're not moving, check to make sure that that's turned on. So that's under special, show with still moving controls. And you can also switch between wireframe and textured. You can do day or night texture. So there's all kinds of menus you can poke around here. So we're done with that menu. So the next thing we need to do is tell it where the center of gravity is. This ball that you see up in the nose is the pilot viewpoint. That's where the pilot sits, and it's also the center of gravity. It's right now at 0, 0. So we're going to have to tell it, well, where is the CG and where does the pilot sit? So the first thing we're going to do is go standard, and then all the way at the bottom is weight and balance. So that's how we get to this menu in your handout. And we need to tell it where the center of gravity is. And the key here is you have to do the first one or the middle one first. If you try to change this one, it says this has to be less than or equal to the middle one. So change the middle one first. And then you can change the other ones. And notice it automatically pops that to be equal to the middle one that we just entered. Same deal there. We can shift the CG vertically up or down from our axis, but we're going to keep it at 0. And then we need to tell it how much the airplane weighs, because it calculates the lift and the drag in the pitching moment and figures out, well, is the lift equal to the weight so it flies, or it's less than the weight and it drops out of the sky. Our airplane weighs 2,000 pounds. And you need to go down and tell it the maximum weight is 2,100 pounds. Notice you can put fuel on board and it calculates the weight for that. You can put jet-assisted takeoff bottles. You can even put a jettisonable load that's water or fire retardant, so you can create a firefighting aircraft that opens doors and drops fire retardant on a fire. Or you can drop another aircraft out of the bottom of your airplane. It does a lot of cool things. So that's the weight and balance. If you really want to get into it, you can specify locations and fuel tanks and where they're located and which ones draw fuel first, so that you can simulate an actual aircraft and how it burns the fuel. Notice the CG ball moved back to where we told it to. So that's the center of gravity. So we're finished with that. The next thing we need to do is tell it some information about where the pilot sits and some other things. So go to standard and then viewpoint. So that's where the next one is. And we need to tell it the stall speed of the airplane. And the do not exceed speed, which is VNE. I'm going to set this really high just so that we don't have any problems. If you set VNE low and you exceed that speed, the airplane crashes. And it's simulating the wings falling off. Same deal with the positive G and negative G limits. If you exceed these G limits, it will simulate a crash because the wings fell off. So we're going to do positive G's of 3, negative 2 G's as the limits for the airplane, because this is just a simple glider. Up here in the description, you can type in the name of your airplane, or the author is you. The description, you can give it a name. And over here, you can give it a tail number. We could call this NA. I went the wrong way. Here we go. NAE 3. '24. So that's our tail number. And I think I've gotten there. Oh, we need to tell where the pilot is. The pilot is going to sit 8 feet back from the axis origin. Well, let me hit the right buttons here. There we go. And we're just going to say he's in the center line. Of course, we could move him side to side or up and down, but we're going to leave those as they are. A lot of other data that we're not going to mess with. So I think we're done here. Positive G, negatively, yep, okay. And so now the viewpoint has moved back here near the CG for the pilot. This other ball is the location of the thrust from the engine. And since we don't have any engines, we're doing a glider, we're just going to leave that alone. All right, the next menu is a lot of details. It's the landing gear. And there's details because you've got to tell it where the landing gear is and how it moves when it retracts and how big the tire is and all kinds of stuff. So this is under standard landing gear. And so each column here is a different landing gear. So we're going to put the gear on the left column to be the nose wheel. And then we're going to have the other two columns as being landing gear out on each of the wings. So this gear is going to be 2 feet aft, whereas each one of these is going to be 9.5. So these are the ones on the wing. So the lateral arm for the nose gear is 0, and it's going to retract 90 degrees backward. And then the second gear here is going to be out the right wing, 8 feet, and it has no vertical arm, and it's going to retract sideways 80 degrees. So they're going to fold up is what I'm aiming for here. And then this one is still located aft, but it's going to be 8 feet on the left side. So it's -8, and it's going to retract the opposite direction. And now I'm wondering why I have 90 on one of those and 80 on the other. I think they both should be 80. All right, the handout shows a 90 where I just put in the 80. And that's a matter of, I think I looked at the airplane and saw whether it went up in the wing and looked nice or not. Yeah, you see the tire radius here is set to 0.01. If you leave the tire radius to this value and you roll down the runway, the tire blows out because there's hardly any tire there and you crash. So you have to change the tire radius here. So I made this one 0.7 and this one 1. And I skipped past leg length. We need to tell it how long the landing gear is. So I did this by looking at the airplane and making these fit. And then you have to give it the width of the tire, again, or it will blow out. So this is a pretty extensive and realistic simulation because it simulates the forces of the ground on the tire and factors those in. So if you hit a really hard landing on a very narrow tire, it will blow out and you'll crash. We want the nose wheel to steer. Notice here it says this gear steers. So we're going to check this box right there. So that means we can steer the airplane down the runway using the nose gear. Then there's another menu here. We need to do gear data because we are steering the nose wheel, and we need to tell it how many degrees the nose wheel can steer. So we're going to make it 40 degrees. And as we go faster and faster, it's going to lose nose wheel steering and switch over to the rudder for steering. And we're going to add a little spring force to the wheel so that it tends to want to return back to center. So you might circle those because there's a lot of data on that page, and those are the only ones that we're entering on that page. So now we can see our airplane with the landing gear and the controls, and it's looking pretty good. The last thing that we want to do is put a control panel in our airplane. And how are we doing on time? Got a few minutes left. So we need to do that. And I also want to show you how we can put paint or color on the airplane. I'm going to try this again. For some reason on this computer, I had a hard time finding the file that I was looking for. The first thing we'll do, and in all honesty, we should have done this a long time ago along the way, is we want to save our airplane. I'm going to do a save as. And inside the installation directory, there's a folder called aircraft. So the X system folder contains all of the files for this simulation. And then we want to put this inside the aircraft folder. And I put it inside the experimental, and I called it AE324 demo. So this is where you'd give it your name and save it as an ACF file. The ACF is a file type for an aircraft. So I'm going to save it inside the experimental folder on this computer. On the computers in here, there is an AE324 folder that you can save airplanes in, but they will disappear if the computer gets rebooted. So what you want to do is temporarily save it inside the aircraft folder, and then once you're done with it, copy it on a jump drive or on your personal drive to take with you. Because again, it will disappear on these computers. And also, when you're doing your design groups in here, or wherever you do them, that's your design group's intellectual property. So you don't want to leave it on the computer here because somebody else can come along and steal your airplane design. Now that's not real critical here, but it's just a matter of security and safety where you always want to take your files with you and delete them off of the public computer that you're staying on. Again, this software that I'm showing you today, if you download the X-Plane 9 demo, is fully functional as the demo version. And in fact, the way that it's restricted is when you go to fly, it's limited as to where you can fly and how long you can fly the airplane. So even the flying version is fully featured. It just, you can only fly for, I think, 6 minutes, and then it shuts off. All right, so I need to save this. I need to type in a name. I'm going to call it Demo 2. And this is where I was having trouble on this computer, is I go find that folder. And I'm not finding that. So I need to debug this. So I might have to delay what we're going to do next until next time. But it should save it, and it should show it as an ACF file in here. And that's what's got me baffled, is where is it putting my file? One thing I do want to check. So make sure X-Plane didn't get double installed. Nope, I'm not seeing it. All right, with the time we have left, which is 2 minutes, I'll show you how we're going to start the instrument panel. We've saved our airplane. So the last thing we're going to do is standard, and then we're going to do a 2D panel. You can do a 3D panel with all kinds of virtual reality looks. We're going to do a 2D panel, and in here is where we drag our instruments that we need for the airplane. We'll start that next time. Again, the best thing for you to do is to download X-Plane and go home and play with it right after this demo. Go through the screenshots so that you can remember where all this stuff is, and it's easy to find. And literally, you can go through this, I'd say 30 minutes. Now that you've seen it, you can go through and click the buttons in about 30 minutes and build an airplane. If you want to fly it, then open up X-Plane, find your airplane, and load it into X-Plane and fly it. We still need to add an instrument panel, so unless you're brave enough to do that on your own, you won't be able to fly right now. Okay, rest of the week, we're going to lecture next time, finish this up. We have homework going over on Friday and then due on Monday with a quiz. If there's no questions, then somebody say something in the chat. Let me stop the share. Oh, today's Wednesday, isn't it? Yeah. No, I'll bring my laptop and we'll meet into Wallace Hall and we'll do it in there. That's typically where I do this anyway. All right, have a good afternoon. Stay warm, stay dry. Thanks for the heads up on the chat. When I'm screen sharing, those don't show up. Yep, have a good evening.